Alrighty, guys, we're live again, and we are doing another Starship reaction stream. So I'm gonna unmute, and we're gonna get watching because they are T minus 27 minutes to launch.
And placed in the
Conditions
launch
pretty
mount.
similar to yesterday, so we
that
could
would
have a scrub for
delay the
weather again.
reusability dramatically and would add a lot of mass with
But
the landing legs. So that's
we'll
why
wait.
we catch
We'll-
the rocket with the
hopefully it'll
tower
go.
arms, because it's the same tower arms that
It's
put
got a
the rocket
50-50
in
chance of
the
going. I
launch
mean,
mount.
it could
Are
go.
used to catch the rocket.
It's hard to know with rockets,
and
right?
that means that we can put the booster back in the launch mount in less than an hour after liftoff. In fact, the booster is going to come back very fast. Like, 5 or 6 minutes later, this booster is coming back one way or another. Or not coming back.
This is the pre-recording from yesterday's stream.
So then you really have propellant full time, which can be brought down to about
we already have
30-40 minutes, and that means it is theoretically possible to fly the booster again in less than an hour.
I think when I think about it, it's the jet drives up to the jetway, the people get off, new people get on, and it leaves. You don't want to land the jet on a different airfield and then tow it over to the jetway. So it's just operationally simpler and faster.
Yeah, we've had a lot of success with the booster. 3 for 3 on the catch attempts. When we bring it back, we've reflown one, so awesome. And then again, Starship superpowers, the whole thing is reusable. So ship reusability is like what we're working on right now. We've been able to get some really spectacular re-entries on a couple of flights, hoping to get this one for re-entry on the V2 ship. But yeah, that fully reusable heat shield, that thing that has just never been done before. That's one of the things we're really looking for that data on.
Yeah, I mean,
I have become the center.
Challenges that remain for both the ship and the booster, but the single, maybe the single biggest one is the reusable orbital heat shield. We are confident in making a fully reusable orbital heat shield, but it will require many flights, many iterations to figure out where the weak points are in the heat shield, where we need to change the design, either strengthening the tile or changing the
live becomes the full screen.
How big the gap is between tiles,
which will probably be in a couple of minutes here.
Changing what's underneath the tile. There's a 100 different variables that we could tweak with the ship tiles, the heat shield tiles. But the only way to know exactly what we should be adjusting is to fly repeatedly and be able to examine the ship upon landing. And we have successfully brought the ship back through the atmosphere and achieved a soft landing multiple times. So we know that this is possible, but we have in the process shed many heat shield tiles. So we need to be able to do this without shedding heat shield tiles.
This is CGI, obviously.
And do so repeatedly.
They have not caught a ship yet.
And I think what you're seeing now is the Starship. This is CG of it coming in
and
and landing
think they
on
will
the
even
tower,
try
much like the booster. But there's some additional challenges there where we need to make sure we don't scrape the tiles off as we.
Assuming this flight goes well,
we can't shuck the heat shield.
We need to keep our fingers crossed.
The ship.
Rapid reusability.
This flight 10's got to go good. Ship 37 needs to perform very well.
So ships can use the tower to land and catch like the booster here on Earth where towers are available. And for our initial landings on Mars and other planets, we'll need landing legs that deploy much like what you're seeing here with Ship 15 when we did our suborbital test to prove out the precision descent landing, which was a successful test. We actually landed two. One was we were able to actually recover it, and you can see it here in the rocket garden if you visit Starbase.
Super crazy to think that these things could be landing on Mars within the next couple of years.
We have actually a whole bunch of boosters and ships, and we'll be adding to them over time. So you can see an evolution of Starship just by driving down the highway.
Yeah. So reusability is key. There's some other technologies we're still looking to prove out. Really big one is going to be the on-orbit refilling.
They're about the same.
To do that next year, and that's really what's going to kind of unlock.
This is in the state that it was then.
Going everywhere.
I don't know how else to say that.
And that's something that's, again, never been done before, kind of like that
roughly
reusable orbital heat shield, but it's going to be something that's kind of some of the other secret sauce to Starship, where we're going to be able to send hundreds of tons per ship to Mars.
Yeah, I like to think of it as if we get to orbit with a full cargo bay, but we're empty on fuel and oxygen. So basically, we're running on fumes. Then we send other ships to dock, transfer propellant, and now we made our two-stage rocket look like a many multi-stage rocket. And we get all of that performance, and we can take that full cargo bay now wherever we want to go.
Yeah,
it'll be interesting to see that in. I can't wait to see that this happen for real.
Next year
this is like one of the most important tests that they're ever going to be able to do. Actually being able to get like tankers full of methane up in orbit would be like, I mean, that would just be, that'd be awesome. Increase mission profiles by like 4 like starships they'd just be able to do anything, like go past Jupiter and all kinds of wacky nonsense.
Tanker ships to refill the Mars ships.
It's a lot of Delta V is what it is.
It can thrust from Earth orbit to Mars and have enough propellant left for landing. So this is orbital refilling is also not something that's ever been demonstrated before. So that would be a brand new technology. We obviously have at SpaceX figured out how to dock repeatedly with the space station. So in a lot of ways, this is like docking, and in some ways it's easier in that SpaceX is docking with its own craft, but no one has ever demonstrated propellant transfer in orbit, to the best of our knowledge, and so this would be propellant transfer
funny. I
at
just
a
watched
very large scale.
I was just finishing the Fishman Island.
But with full
rework
reusability
thing.
and propellant transfer,
So the General Frankie,
those are the key technologies needed for building a city on Mars. And I'm confident that the SpaceX team, which is incredibly talented, will achieve these goals. And we will be landing ships on Mars in the future and building life on Mars, building greenhouses and life on Mars, and ensuring the long-term survival of life as we know it. And it's important to note here that obviously, we are effectively stewards of life here on Earth. That the other creatures cannot build spacecraft and get to other planets. So if there were to be a cataclysmic event, like a giant meteor that destroyed the dinosaurs, or ultimately the sun will expand to envelop Earth and destroy all life. We know this is an undisputed fact.
Right, T-minus 20 minutes. I have no idea how the weather is updated or anything, because we got Elon chat from yesterday instead of range updates.
And ensure the long-term survival of life as we know it on planet Earth.
We will see.
And I mean, aside from that, there's so much that Starship unlocks by being able to
weather
do these
was
things.
55%
go
last I checked.
There are
I guess I could pull it up on Twitter.
Transformational things by being able to take that many people, that much stuff to space for that much less money.
Or, sorry, not Twitter.
Understanding our planet better, being able to move people around the planet, make it feel smaller and more accessible. You could go anywhere on the Earth, in less than 40 minutes, basically, in terms of flight time. So I really do see Starship as being this thing that can connect us, just like Starlink connects our information.
I don't want to have to react to this twice.
Physically.
Yeah. So there's really nothing faster than a rocket.
An intercontinental ballistic missile.
Thing that we know of of the fastest means of transport. So, like, you could go from LA to Sydney in less than half an hour. You could go LA to Tokyo in less than half an hour. You could go from New York to Singapore in half an hour.
Dude, give me the Tokyo Express, the hypersonic Tokyo Express.
Some things might be 10 minutes.
Yeah, that's true.
I mean, sign me up for that,
they
please.
They are 55% favorable for liftoff. At the opening of the window, so I don't know.
You're going 25 times the speed of sound, so that's 30 times faster than
that means right now.
Commercial aircraft.
And it's a whole hell of a lot better view.
Yeah, it's a hell of a view.
Yeah. All right, cool. Anything else, guys? Anything else?
Well, we could say a lot more.
Maybe we should go check in on the rocket and get on console.
We're going to go back on console to hopefully the weather supports a launch tonight. And
same for today. That stays true today.
Yeah. Thanks for your support.
All right. I guess that's going to disappear now. Sick.
All right. Obviously, that was really cool. There's probably not anybody else cooler on the planet to talk Starship with. Still very ready to sign up for that point-to-point travel, too. Also, though, it's really hard to realize.
Dude, honestly, that would be sick. Like that is definitely one of the coolest points of Starship. Being able to go from like, I don't know, again, like LA to Tokyo in like 30 minutes, that would be pretty awesome. Like you cannot deny that would be a pretty pretty cool trip.
Yeah, if you were to stack Starship up against one of the biggest airplanes out there today, the 747, just one Raptor engine is double the thrust of all 4 airplane engines. Super crazy to think about.
It's not very fair,
and the
though.
Super
It's
Heavy
not the
on the
same
pad
type
right
of
now,
engine.
which has 33 Raptor engines, is putting out as much power as about 64 747s.
This is not a fair comparison.
Yeah, again, just a tremendous amount of power.
Poor plane.
World's largest flying object.
Cries in weakness.
That was really cool to just go through that. I love to geek out as much as everybody else over all the nitty gritty, but always important to remember there's a lot of people that just don't know that all of this is happening.
Those clouds are looking better than yesterday.
To remind them.
That's
cool
for
everybody else out there.
This scene looks better than it did yesterday.
So right now we are
from my amateur non-weatherman eyes
and counting until the 10th Starship flight test. While we do have a moment,
bro.
Let's check in over with Tyler Lindquist over in Hawthorne for the latest on Starlink. How's it going,
Tyler? Sit here.
Thanks, Dan and Amanda. I'm Tyler Lindquist, and I'm a Starlink business analyst here at SpaceX.
Although the damage
Starlink
is already done.
SpaceX's low Earth orbit, high-speed internet that's bringing connectivity both on Earth and in space. Now, for today's mission, Starship is outfitted with 4 Starlink terminals, allowing us to get live views of ship while in orbit and all the way down to splashdown.
The live views are the coolest shit. I love
Our
it.
Starlink satellites are built in Redmond,
Get to see
Washington,
that plasma
which
build
is
up as the ship
the
re-enters.
health of the entire constellation.
Fingers crossed it gets to
let's
re-enter
take a
this
quick look
time.
for more on Redmond.
Oh, we're getting the Starlink video
might
again.
Not realize when they think about the scale that we're operating is that
we're getting all the same stuff as yesterday. Well, obviously they're gonna do all their promotional videos and everything. So
right here in Redmond. We've currently got a constellation of over 8,000 satellites that are flying around in orbit. So they're working together to fill out the whole surface of the Earth, make sure everywhere
it's a good sign. Good luck for the launch, you know? Oh, Lord.
Between the satellites, so each satellite can pass data from one to the other. That is what allows us to have these hundreds of gigabit links between satellites, and that's what allows us to connect every corner of the Earth to high-quality, high-speed, low-latency internet.
Space lasers.
When you think about that Starlink that you have at home, the technology that's in there and that's in your antenna is very similar to the antenna that's on the satellite. We use what are called phased array antennas, which is a fancy way of describing an antenna that's made up of many little antennas that work together in order to direct their energy to a specific spot on the ground without a motor.
Generally, satellite manufacturing is a very slow process. It takes people weeks or months to build a satellite. At SpaceX, we iterate very fast, and we have learned how to build satellites at the 70 sats a week rate.
Just the oddly satisfying automated factorial brain.
Rate, we have not forgotten about our satellite reliability, which is critical to our mission.
If you look at the whole world and you ask, where is the satellite industry? It's right here in the USA, in Redmond, where the vast majority of satellites being built are being built right here. Starlink is a truly game-changing technology, and it's all supported by the global satellite constellation from this space here in Redmond. And we're really just getting started at the very beginning of what we want to do with Starlink.
Yeah, they are. Because once Starship is working,
now, as we mentioned earlier in the show, one of today's objectives is for SHIP to deploy Starlink simulator satellites that represent the advanced V3 satellites Starship will be launching in the future. And as you can see here, once Starship reaches a nominal orbit, the payload door will slowly begin to open to prepare for deployment. The Starlink satellites will be dispatched relatively quickly, one at a time, like a Pez dispenser, as you can see on your screen.
I wonder what external camera views we'll have of this.
Taking up as little space as possible, allowing for an efficient deployment sequence.
Like if they'll have one looking down right here, or like,
the next set advances and
probably
deploys
not
until
actually.
they are all drifting away from Starship to prepare for their on.
They'll definitely have an internal camera that'll probably look
Starlink
something like
V3
this.
launch on Starship is planned to add 60 terabits per second
Very
of capacity
interested to see what that all, what the mechanics of that all looks like.
Capacity added with every V2 mini launch.
Man, this launch is just so exciting. I really hope it goes
today.
We have 13 minutes left before they
which will ultimately enable Starlink
probably
to serve as the communications
will have a slight hold before launch. I think it's at T-minus 40 seconds.
Now, we're going to turn it back over to the team at Starbase.
Thank you so much, Tyler. Okay, let's turn our attention to today's flight profile, which will feel familiar because it is. We're looking to get our first re-entry with this iteration.
We were definitely not here doing the same thing yesterday.
Stressing Super Heavy during its return. The next generation booster is on the horizon, so the objective is to push and learn all we can from this current version.
All right, let's jump right in. As always, it's going to start with liftoff. Super Heavy ignites 33 engines lifting off from Starbase and ascending. It's going to power that ascent for about 2.5 minutes until we get to hot stage separation. Super Heavy shuts down all but 3 engines, deeply throttles the remaining ones, stage 2 lights its, and flies away. We have stage separation, a directional flip. It's going to descend. We're going to do some landing burn experiments and then do a splashdown in the Gulf.
Meanwhile, ship continues on with its ascent burn, again reaching a planned suborbital trajectory. We'll attempt to deploy 8 Starlink simulator satellites and then head back for re-entry, where we'll be testing multiple experiments, including missing tiles, metallic tiles, and intentionally loading the vehicle's flaps. Ship will also attempt a flip maneuver, and if all goes as planned today, we'll conclude the test with a soft water splashdown in the Indian Ocean. So that's what we have on deck for Flight 10, which is just about 11 minutes, 40 seconds from launching.
That's right. And so just a quick status check.
It starts going so quick.
11.5 minutes away. We have some good news. We got our latest range and weather status, and surprise, everything is looking green today. So that's the biggest news that we were looking for. Again, weather is the main watch item for today.
It looks so much better today.
We're not tracking
those clouds don't look good, but those aren't close enough. That's not a problem.
So we are
they're looking good.
For launch. We did all of our normal pre-flight checkouts.
Oh, my foot
with
is
all
itchy.
the different vehicle and
so much itchiness today.
At this very
good
moment,
signs.
We're almost done.
Good luck.
We're pretty far into our prop load on ship, and a little bit more to go on the booster.
Yep, looking closely, it looks like we're nearly closed out on ship, like Dan said, about 70% of the way through on both methane and LOX on the booster side. We'll continue loading prop for a while. We'll close out at about T-minus 30 minutes, 20 seconds on ship, and then 30 seconds later, we'll finish up loading prop on the booster.
Yeah, so bottom line, a little over 10 minutes to go. Range is green, weather is green, vehicles looking healthy. We're looking good to launch right at the top of our window at 6:30 p.m. Central Time.
Can't wait. All right, now let's quickly talk about Mars, since everything we do is part of our foundational mission to get to the Red Planet. Each Starship launch is to learn more and more about what's needed to make life multiplanetary and to improve ship to the point where it's taking millions of people to Mars.
Yeah, we've shared the plan previously in the last couple of months. We're looking to start sending the very first Starships to Mars next year. These missions, not with people. We're just looking minimally viable landers, so let's just prove that we can get there. And so we're just going to focus on learning as much as possible, but looking at all of those different phases. You know,
they got to get a successful launch first.
Prop transfer on orbit, sending stuff out to Mars, doing the transit, doing the entry, and just doing the landing.
And in our next window, around 2028 to 2029, we're going to attempt to land the initial infrastructure and start delivering more equipment as well, while evaluating available resources on the Red Planet. And we will also have Optimus on board for the ride, who is designed to do the initial heavy lifting.
I love
looks like we're doing some flap checkouts real quick on the ship as we are coming up on 9 minutes. Back to Mars, though, as those wrap up by about 2030, 2031, we'll continue to increase the payload per ship, build out more infrastructure out there on Mars's surface, start to mine some of those resources, set up some propellant generation plants, build up some fuel and some oxidizer to send Starships back from Mars. By the time we get all the way to 2033, we're looking to double the amount of payload we're sending with each ship as we get closer and closer to building a self-sustaining presence on the Red Planet.
Yeah, definitely lots of exciting missions ahead of us. And these are going to be crucial to setting up what we'll need for humans to eventually inhabit the planet, and we won't be doing this alone. The Italian Space Agency and SpaceX recently signed a first-of-its-kind agreement to carry Italian experiments on the first Starship missions to deliver customer payloads to Mars. So these payloads will include a plant growth experiment, a weather monitoring station, and also a radiation sensor to gather scientific data during Starship's approximately 6-month interplanetary coast phase from Earth to Mars and also on the Martian surface.
It's a really exciting mission, makes showing up for work really fun for us. We're going to need to launch a whole lot more, though. So while we're just under 8 minutes away from launch today, let's head back over to Tyler and Hawthorne, talk a little bit about how we're going to be increasing the number of Starship launches going forward. Tyler?
Thank you, Dan and Amanda. So to put it plainly, in order to launch more Starships, we need to build more launch pads. And that's exactly what we're doing at Space Launch Complex 37 at Cape Canaveral Space Force Station in Florida. Now, Pad 37 has a storied history.
Is that a guy eating a banana in the background? Hell yeah, W banana.
And missions for the U.S. government. And prior to that, the pad supported
there's all a bunch of bananas. Hell yeah.
Apollo lunar program.
Banana W. Fuck yeah.
And we are honored to have the opportunity to continue making spaceflight history at Pad 37 with Starship. But first, we need to optimize the pad. So earlier this year, we started dismantling some of the existing infrastructure to prep the site for Starship operations. This will include up to 76 launches a year, with up to 152 landings at that location for Super Heavy and for Starship. And to support this flight rate, we plan on building 2 launch pads. Each will have 1 tower that can support launch and landing, plus deflector systems, launch mounts, and water deluge systems. This will also include a propellant farm that will produce propellant on site and serve both launch pads. So there is a lot of work in progress, but Pad 37 is only one part of our plan for Starship operations in Florida. A few miles away from Pad 37 at Kennedy Space Center, our 380-foot-tall vertical integration facility called Giga Bay is under construction.
Oh, the Giga Bay.
Once complete next year, Giga Bay will be capable of housing multiple Starships simultaneously for rapid assembly and integration. And meanwhile, at Launch Complex 39A, we're building Starship's infrastructure to support up to 44 launches and up to 88 landings a year, independent of operations at Pad 37. So with 2 launch complexes in Florida, we'll have the ability to fly up to 120 Starships annually, not including our flights from Starbase.
That's a lot of ships.
Action is well underway in Florida. How's it looking in Texas?
Thanks, Tyler. Things are continuing to look good for launch here in Texas, so getting pretty close here with just under 6 minutes left. You mentioned Giga Bay. We're currently laying the foundation for a Giga Bay here at Starbase as well, and we expect it to be up and running sometime next year.
It's a lot of Giga Bays.
Yeah, there's a whole bunch of Starships on the way, and we're going to need more hands on deck. So come help us build the gateway to Mars. Visit SpaceX.com/careers to see all of our openings.
Yeah, I've been here for a couple of years now. Nowhere more magical, more inspirational on the planet. If you're a space nerd, you can come be like Amanda and build these things for real. It's pretty insane. It's super exciting. And yeah, come check us out. All right.
Absolutely. It's surreal to be here for sure. Okay, so we are looking like we're about 5 minutes away from launch and heading into terminal count. Range and weather are continuing to look good, and prop load continues on both stages of Starship. We'll close out here in just a minute or so.
Yeah, we're just about done. It looks like, let me grab my numbers real quick. We're not tracking any issues. We are just creeping up to 90% full on the LOX on the booster, a little over 93% on fuel on the booster, and then ship we're just about to close out, so only a couple of minutes to go there. Once we're done, you've got just shy of 11 million pounds of liquid propellant on board those 2 different stages. We'll see a couple of final things happen. Well, you can't really see it. It's all going to be happening in our ground systems as we'll do pushbacks, clear all of the propellant out of those lines that are flowing up through the tower and into the vehicles, and get ready for launch. We just did our final guidance, navigation, and control system checkouts. Our flight safety system is being armed right now, and we're doing our final wiggle checks shortly with the engines on the thrust vector control. It's how we're steering the rocket. If we need to hold, which we are not currently tracking a reason to hold,
that sounds like everything is going good.
-40 seconds. You saw us do that yesterday. We can hang out there for about 8 minutes or so right now. That's the point. It's built into the countdown. If we need to wait for
like
clouds that just won't go the heck away or any other issues, we can hang out at T-40 for a bit. But at the moment, we're not planning to do that.
Now, once we pass that T-40-second mark, a number of events are going to occur in rapid succession. The ground spin and ignition systems come up to flight pressure. Ship will switch over to internal power, and after that, the QD arm lockout is removed in preparation for retraction, which occurs shortly after T0. And once we pass that T-40 seconds, we do still have the ability to then recycle the count under certain conditions back to T-40 seconds and hold there to assess what happened, and if we can proceed again back down to liftoff.
That's right. We do have at least one point of no return, though.
That's the hold your breath moment.
Water-cooled flame deflector underneath the launch mount fires off. That happens a little bit after T-10 seconds. That doesn't turn off once it starts going. So we would have to stand down for the day if we do hit a hold or an abort at that point, so we can refill water tanks. At this point, we're not sure if we'd be able to attempt tomorrow because we have fully loaded the vehicle. We have to do a lot of fancy scheduling to get propellant in here as fast as possible.
Yeah, I figured that they wouldn't be able to do tomorrow.
Pretty heroic and amazing team that works all of those logistics. Got us into our attempt today. After we did
today is looking good. I'm feeling optimistic about this.
So really excited.
Fingers crossed.
But we're coming up on 2 minutes.
Flight 10.
A green range. We are green for weather. Green has always been my favorite color, only more so now. And we are not tracking
green weather. That is much better than where we were yesterday.
Looking good. 2 minutes to go.
Yeah, again, not planning on holding at T-40 seconds right now, but in case we do pass that and any issues come up, we can recycle the count. We're pretty lucky that we have this ability. Falcon doesn't have that built in, but being a developmental program, this affords us a lot more flexibility, so super useful to be able to have that. But again, not currently tracking any issues, so hopefully we'll be good to launch today.
All right, coming up on 90 seconds, we've got a pretty good crowd gathering with us right outside Star Factory here at Starbase.
Are we going to get to watch the gimbal test?
We're getting a quick TVC, that wiggle check.
This is my favorite view of the rocket.
Right under the launch mount.
It'll be sick when Raptor 3 is in and no heat shields.
All right, so it's my favorite view of the rocket. Crowds gathered out at Hawthorne, crowds gathered
it's
here
the business
at
end,
Starbase.
so to speak.
Super fun to see people getting to watch out on the front lawn now.
All right,
we're 1 minute to go to launch.
1 minute now.
All right, so again, our hold point comes up at T-40, not tracking any reason to stop there, so we should see us go right through that.
Yeah, right through. Okay.
All right.
Here we go, guys.
Through T-40.
We're green
counting down.
And maybe going. I think we are going. It is going to go.
Ventura take us the rest of the way. 30 seconds.
Ship 37 and booster 16 on Starship's Flight 10.
T-15.
No booster recovery today. In the business end now.
9, 8, 7, 6, 5, 4, 3, 2, 1.
And
we lift
off.
Vehicle pitching downrange.
Hell yeah, it is. Look at it go. There it is, Flight 10 on its way. All engines look good. Hell yeah, dude. Oh, man. Listen to those.
All right, we're a little over 40 seconds.
Listen to those engines roar.
Avionics power and telemetry nominal.
Getting good call outs, healthy systems on the booster as it starts to pitch over the Gulf.
Oh, that's sick. Little cone that formed.
All right, we're a little over 1 minute into flight, about to pass through Max Q.
Max Q.
There's Max Q.
All right, so we are through the period of maximum dynamic pressure, max stress on the vehicle as it continues to fly.
Our next major event is going to be hot staging, which is happening in just over 90 seconds from now. To get ready, the booster will shut down all but 3 of its Raptor engines. The clamps holding the 2 stages together will release, and the Starship second stage ignites its engines. The ship then separates from the Super Heavy booster and heads to space. At the same time, the 3 engines still firing on Super Heavy will flip the booster around. 10 more engines will ignite for the boost back burn, putting the first stage on the path for splashdown in the Gulf. As we mentioned earlier, the hot stage will be jettisoned for this flight, and that should occur just after the boost back burn. So we're about to shut down the first stage and perform hot staging. So let's just watch and listen.
That'll still be a few seconds here. There's engine shell, I believe, of the second stage engines.
All right, seeing the engine start to throttle down.
Miko.
There it is, main engine cutoff. We should see hot staging here.
Boost back burn startup. Stage separation.
Oh, and it looks like they're only down 1 engine.
Stage separation confirmed. We've got 6 engines running on ship. Booster is doing its boost back burn, continuing now towards its splashdown site in the Gulf. We are seeing all 6 Raptors lit up on ship.
Now let's see if that soft booster splashdown goes well. And then we'll see if ship survives.
You heard them report ship chamber pressures nominal, so that chamber pressure, just that expected thrust level in those Raptor engines on the ship. 3 vacuum optimized, 3 sea level, all looking good. There's a view into the business end from the ship.
Boost back burn shutdown.
The business end, yes.
All right, so at this point, we finished our boost back burn, so that was shut down. So that's the first of the 2 burns after a launch that the booster is going to do today. So now it's
keeping an eye on
headed towards the Gulf.
The ship is looking good.
It's not going to be quite as aggressive of a flight down. We relaxed that angle of attack a little bit.
It's not spinning or
we are then going to be looking
yet,
for it to do
its
engine tests for the landing burn, and those are going to be a little unique this time.
Yeah, typically we start with all 13 inner engines lit for that landing burn and bring that down to just the center 3. But one of our test objectives for today is to simulate what an engine out situation would look like. So we're going to be intentionally turning off one of those center 3 and instead lighting one of the engines from the middle 10 ring.
Okay.
Yeah, we did see one of those engines in the middle ring shut down
there's the hot
during
stage
the initial asset.
Looks
like we have
That's
hot
cool.
stage jettison. You can see it floating away there.
Oh, such a cool tracking shot. Look at how, and then you can see that's like an awesome demonstration of relative velocity.
We are resilient to engine
like showing them both on the same trajectory there, but just slightly varied. That's a very cool shot right there.
Starship flying on the expected path. There's still a chance that engine could be back in the mix for the very start of the landing burn, so we'll see if we light up all 13. But we've even done a landing burn at the tower with an engine out, so very resilient. We'll see how it does on its way down to the Gulf, though.
Yeah, again, no catch today, so just
landing burn start.
Just a soft landing, soft splashdown of the booster.
Away.
What we're really interested in is how the ship here is going to perform today.
That's always rad. You can see the.
Oh, look at the heating.
See the boost plume itself in the background as it was coming in.
There's so much friction from the air running up against that it's actually like heating up.
20 seconds to landing burn.
Ship Raptor chamber pressure is nominal.
All right. Come on, booster. Come on, booster 16.
All right, here we go.
Landing burn
Okay, that engine is still down. But that's okay. They can do it without. Oh,
like
okay.
We got 12 of those 13.
And then there are 3.
Oh, yeah, 3, is it doing it? One of the middle ring.
It looks like it's doing it. Nice. So even with an engine out, they just take that engine and it works.
Down to 2.
Wow.
Nice little hover.
Gentle little splashdown.
And landing burn shutdown.
Into the Gulf there.
And into the Gulf. Here we come.
Wow, that's a cool little shot.
And the booster
that's awesome.
Has splashed down.
So that looked like a fully successful test to me of the booster there. That was awesome. Hopefully we'll get some offshore footage of that later on today.
About 7 minutes into today's flight, ship continuing its ascent burn.
Again, it's so quick,
about
7
minutes into our flight. That ship engine cutoff is slated for 8 minutes and 57 seconds.
All right, so where everything went wrong last time was right here.
The Raptor vacuum engines, those are the bigger circles, and that little indicator on the bottom
Come
right
on,
of your screen,
ship.
those will shut down first.
It's going 15 times the speed of sound right now.
Burning for a couple seconds longer on those inner 3 before we hit SECO, second engine.
So it's doing something right.
Yeah, these views are looking great. Once again,
that was
thanks
awesome,
to Starlink
guys.
For getting us these views.
These launches are so
incredible.
Cool, and hopefully we'll get another one pretty soon. Hopefully around the middle of September, or hopefully around my birthday in September.
Heard the sound from
that would be awesome.
It's like
that'd be a great birthday gift.
A late boom from the booster.
All right, they're rapidly approaching second engine cutoff.
Yeah, we have ship engine cutoff coming up here just shortly. And as we mentioned, today's flight test is not an orbital flight, but rather one that demonstrates
second stage
Starship's
was what I was
capability.
Starship from terminal guidance.
It's ship in this case, as it is a Starship.
All right, entering the final phase of this burn.
Wow, look at how quickly it gains speed at this point. Like how much, it's just so amazing to see, to be honest with you. I love things that go fast.
All right, shut down the vacuum engines.
Okay. No fires yet.
Ship engine cutoff.
We shut down the center 3. Successful ship engine cutoff.
Uh-huh.
SECO, baby. There we go. That's what we want.
Nominal orbit insertion.
All right, we just heard the call out for nominal orbital insertion.
Yes.
All right, so ship is in space. There we go. Seeing the flaps
moving.
To move
that's
into
so
a stowed
cool.
position. That's why it looks like your camera's moving.
Oh, that's so cool.
Yeah, exciting to see Starship safely in space, and super pumped to see all the team's hard work in action here today. And of course, as guaranteed, it's been an exciting day so far. We successfully lifted off right on time at 6:30 p.m. Central Time. Thankfully, our weather was looking good today. Yeah.
Wow, that's super cool.
We had our soft splashdown in the Gulf, so ship continues on.
Yeah, ship able to complete its ascent burn all the way in. You can see some of the shadows start to creep as it's going to be eventually flying into an orbital nighttime. So we'll see
the dark side of the planet.
Some daylight start to go away. But ship is in orbit, completed its burn. And,
wow, that cloud looks so
just
cool.
The beginning. Now we've got a whole bunch more to go. So we've got some exciting demonstrations planned while we're on orbit.
Okay, FTS saved.
That right there, we just saved the FTS, the flight termination system. That's that automatic flight safety system we have on the vehicle. So that is now turned off while ship starts its coast period. We are coming up. Our next milestone is going to be the deployment of those Starlink simulators. We've got some payload inside of Starship that we're hoping to deploy into space for the very first time. That deploy is supposed to start at about 18 minutes and 27 seconds into the flight, so just about 7 minutes from now. That deploy will take place over a couple of minutes. It'll go about 1 satellite a minute. So we'll be spread out over that. It might get a little dark, but we've got a couple of views that we can show you to see that deploy in action. After that, we're also looking to do a relight of a single Raptor engine while we are in space. We've done this once before. This is not necessary to deorbit, as we are in a suborbital trajectory, but this is essentially a chance to test out what we need to be able to do a deorbit burn. So we'll be doing that a little bit later in the flight, about 37 minutes or so into the flight. And then we get into reentry. We're looking to get that light show and, more importantly, get that really critical data about the ship's heat shield.
Yeah, exactly. At about T+45 minutes, we'll be heading for reentry. Again, running those experiments with the tiles. We're going to be doing missing tiles, metallic tiles, and also intentionally loading those vehicles' flaps. Hopefully, we'll also see a splashdown in the Indian Ocean today.
Yeah, we were able to get to a reentry last time, but we didn't have full attitude control, so we weren't able to go in, heat shield first the way we're designed to. So we ended up losing contact with the ship before we could make it all the way through. So you still get data, but you're not really getting the data that we want to make sure we're kind of stress testing the vehicle. As Amanda just said, we removed a bunch of tiles, and we do this in some intentionally scary places on the vehicle because we're really looking, are there spots that were vulnerable to this before we ever start moving towards, putting ship into a full orbital mission to then do reentries a little bit later on. So really, really critical to get that data, really looking forward to a controlled reentry.
Yeah, for sure. As we always say, our main payload is data, but today we also have some actual payload on board, and those simulators that Starship will be deploying, we'll see coming up here in just a few minutes. These are dummy satellites that are about the same size as our V3 Starlinks. We have 8 in the Starship PEZ dispenser and expect to deploy at a rate of about 1 per minute, as Dan mentioned earlier. Starlink is critical in all of our flights on Starship to get our main payload data, as we always say. And in fact, it's Starlink that's currently providing these views you see as Starship cruises a couple hundred kilometers above our home planet and provides real-time telemetry through every phase of flight.
Yeah, we took a peek inside of the Starship payload bay there for a second. So there's 8 of them there. They kind of look just big steel plates, essentially. They're roughly the same size as those V3 satellites. When we do get that view inside of the payload bay, the payload door will kind of be on your right, and we'll start to see them go out like a PEZ dispenser. Yeah, here's a look inside. So those right down there in the center, they're kind of 2 stacks of 4 on either side, and then the payload door is just to their right. And so we'll look to see that open, and then those satellites start to go. We vent the nose cone, so we essentially bring it down to vacuum before we open the door. That was one of the things we ran into on the last flight, as when we had that fuel diffuser fail, the pressure in the nose cone became basically too high for the actuator of the door to open. So that's why we weren't able to get the door open that time. We have not seen anything like that on this flight. Everything's looking good with our fuel tank and our fuel press system. So we are hopefully just a couple of minutes away from seeing that payload door open and getting to our first ever payload. It's not the first payload we've ever carried, but it's the first one we're going to try and shoot off into space. All right, so I think we're supposed to open the payload door in just about a minute and change. And you're seeing a little bit of residual gas. And we opened the door once. I want to say it was back on flight 3 when we were able to make it up into space. And you'll kind of see a lot of that gas rushing out into the vacuum of space. It's the residual that's left over after we've already vented it down. So kind of a cool light show. And then we'll get ready to deploy those payloads out. And as we mentioned, so we have crossed over now at this point into an orbital nighttime. So views from the outside will get pretty dark, but we'll see what we can see. We do this by design. We've been launching these later in the day here in Texas to try and get daytime views when we splash down. So it's daytime over in the Indian Ocean, where we are currently headed.
Just a few seconds until we expect those payload doors to open.
Okay. Payload doors opening soon. Then we'll see
all right,
what ends up happening.
Open the pod bay doors, Hal.
I can't do that. I can't do that, Dan. Oh, there it is. They must have opened, or maybe? Yeah, they must have opened it because everything just got sucked out. Oh, it's opening. Look, it's fucking opening. Dun, 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 dun. Hell yeah. Look at that. There it is. That's sick.
So we are currently in payload deploy prep.
Okay. Now we just have to see whether or not it actually deploys them. This is going much better than last time. This is awesome.
And the door is open.
All right, now start you just yeeting those things out of there.
All right, so the payload door is open. We should see the first satellites start to deploy at about T plus 18 minutes and 27 seconds. So should be only about 30 seconds. So one step closer. Hal listened this time. He cooperated. He opened the payload door for us.
Hal did listen. Hell yeah.
There's a view kind of behind the Pez here looking out into the vacuum of space.
About 15 seconds until payload deploy.
Oh, don't give me no schmungo quality cameras. We need to be able to see. We need to see. This is important.
Ship has transitioned to payload deploy.
I was told 27 seconds. I've been lied to. Let's go. You could do it. There's like a chain there. Is that thing gonna start like whirring and like send them flying? That's what I hope so. Come on. Oh, it's doing a thing, guys. It's moving. It is the chain. Yoink. Yes. Look at it wiggling. All right, the first one's out of there.
Pew pew.
Second one moving out.
Been waiting way too long to do that. There we go.
Yoink. And it just
another one.
Flies away. There it goes. Bye. Oh, awesome.
Super exciting moment as you can hear the energy in both Hawthorne and Starbase.
Yeah, I mean, they've been planning on doing this test for a while, and now it's actually working. Which means that hopefully they'll just be able to
next row.
They'll be able to launch like an actual payload.
Said, we're going to do about
on some of the next
one every
tests.
minute or so, and this is just kind of a dress rehearsal for when we're going to be deploying the V3 satellites, and these are just a massive increase to Starlink's capability. Each one of them has it's 60 terabits per second of capacity that's going to get added to the network per launch. That's 20 times more than what we're adding with every single Falcon 9 launch today, which, you know, step increase in capability. There goes another one.
Come on. Oh. It seems like it didn't come off the rail.
All right, so as we said, we've got 8 total that we're going to go through today. It's about a minute for each one, but looking good on payload deploy.
They got to send that one with some extra speed. Hell yeah, there it goes. For something moving 26,000 kilometers an hour, these things sliding out at a snail's pace, although they are also moving 26,000 kilometers an hour. Another good demonstration of relative velocity. Oh, wow, that system is cool. Everybody just holding their breath, waiting for these things to go, and then when they go, everybody's like, yeah! Well, here it goes.
Right,
it's doing a thing.
So we're about halfway through. When we actually start launching the V3 Starlinks on Starship, we're going to be flying about 60 each time. So it'll be about an hour to get through a full stack. But again, it's just going to be a massive increase in the amount of bandwidth. It's going to enable, gigabit upload, download for people with Starlink anywhere on the planet. And for us, Starlink is just a tremendous part of just the Starship flight test program.
Yeah, absolutely. Always getting us that data, and yeah, the amazing views we have on the vehicle today.
Yeah, views brought to you by Starlink of us deploying Starlink simulators before we deploy actual Starlinks.
I heard you like Starlink.
How deep does it go? All right, another one firing out.
Now they have a couple more to go. Well, this has been one of the most successful flight tests so far. Now we just have to see, does the ship survive? Does it survive re-entry and land softly? And if so, then I think we're seeing a catch, maybe I was wrong. Maybe Flight 11 will have a catch for Starship. And then it like pinches it, and then it pulls them up from the stack. And then the belts bring it forward. Cool. What a cool view of this system in action. Oh, it looks like they didn't quite get it.
We've got one left.
Almost there.
Oh, I see. So they get one out, and then and that way they can do 2 at a time. So there's like the front and then the back one, and then so it pulls back.
There you go, one
all
remaining.
The way,
so 7 of the 8
and then gives it some time
deployed. One more to
for
go,
the ship to move along.
And then we will have completed our first ever payload deploy operation.
Throw out the last one.
Just a reminder, we're on a suborbital trajectory. These satellites on that exact same suborbital trajectory, they're going to burn up entirely.
Very good job, SpaceX.
So
congratulations to the teams.
Has been deployed.
That's some very hype stuff.
Payload complete. Heck yeah, everybody.
Good work.
Loving the energy from Starbase and Hawthorne.
There, now it's empty. Looking a little lonely, but
successfully deployed all the simulator satellites.
Really, really cool.
Now I wonder. Oh, thank you for the follow, Remton.
Again, people that have followed know Starlink's really critical for the Starship program. In addition to getting all those views back from the cameras on Starship, which this is an external view. As I said, it's dark outside right now. The lights are off.
Yeah,
so
you can't see much.
It's going to be hard to make stuff
on the
out.
Dark side of the planet.
In a little while, the sun's going to start coming up as we get to re-entry, which is going to be really critical.
Look, they're already halfway across the Atlantic.
We use Starlink for Starship data. Cameras also use it on the cameras that we use to bring you views of these launches and also, hopefully, of the re-entry and splashdown. We'll see what we get from the Indian Ocean today. And that's just kind of how it all comes together. Like, we're using Starlink. on the planet, off the planet. With Starship, we actually get pretty insane.
I don't know. Are they doing an engine relight test
bandwidth to space is
in orbit
usually
today?
Pretty minimal. We get about 120 megabits per second. That's split between our high-definition video and real-time telemetry. We get that every phase of flight, including reentry. So it's not just giving us views of reentry, but we're getting all of that engineering data in real time
splashdown of booster
through phases that it used to be impossible to
beautiful
get
launch
in real time. So just really
there was
incredible.
the biggest rocket
definitely
that people have ever made was sitting there
and
26
the
minutes
world's
ago.
largest satellite constellation operating in
it's
low
flying.
Earth orbit to deliver high-speed, low-latency broadband internet. This provides internet access to people all around the world, many of whom had never had connectivity before. Today, Starlink serves more than 150 countries, territories, and other markets, with over 6 million active customers and counting. To meet the growing global demand for high-speed internet, SpaceX expanded its factory in Bastrop, Texas, and also introduced Starlink Mini, as well as an upgraded version of the Starlink Standard kit.
All right, now with payload deploy complete, Starship is now going to close its payload bay door and continue to coast towards Earth, around Earth, towards the Indian Ocean. Sorry, I'm really excited today. We are in space, people. Still a lot of major events to come, though. We are looking to relight one of those Raptor engines.
Yes, okay, they are. Okay, nice.
33 seconds into the flight.
37 minutes and 33 seconds. Okay.
And splashdown. So,
okay.
We're going to go on a quick break, take a quick coast, sit back, enjoy the views. A little bit dark now, but they'll get better soon. A couple of space jams. We'll be back in just a few minutes for that Raptor relight and then re-entry. See you soon.
All right, I think I have to mute it because this music is copyright. So, all right, and then I'm booting up Factorio for my boys. Let me just swap over to the big cam quickly. We do games. I do games with my other buddies off stream, usually today. Let me just make sure that this is right. Yep. Okay, pause, and then we will invite everybody. Or not, because it's afraid of opening my friends list while I'm streaming. Even though I've got it off. I can fix this though. Invite, and invite. All right. Now we'll flip back over to this. My camera will not be working until I do that. And we'll just Yeah, still music. Well, this is the longest it's gone so far. We had a second engine cutoff, no problem. The ship actually seems to be like in a good orientation. They have this like orientation thing here. It doesn't appear to be spinning wildly out of control. Looks like it's going to cross over Africa here, and then we're going to be into our into the landing side of things, which is very exciting since we have not had one of those in a while. Okay. I guess I don't want the music, that's right. I don't want to get hit by the hammer, the copyright hammer. Everything else is fine. Like the SpaceX streams, like you're allowed to use all this, like all the stuff that SpaceX themselves is putting out. They want people to share and use and whatnot. But the music is there was a couple flights where people were getting hit for the music, and I just don't want to risk it, so I will not. Today was an awesome flight, though. That was absolutely sick. Oh, there's a flap image. You can sort of see the sort of see what's going on there. I mean, it's still very dark, but soon they'll get around the planet a little bit more. I might pop over to the big cam again in a second. So that I can unpause the Factorio, save for the boys so they can get working on things. Then I'll join them. I'll join them afterwards. After the stream has concluded. After ship has splashed down. Which will be a little while yet. But we've got that test coming up in about 3 minutes here. Well, there's the business end. We're going to see a relight from this side. The wacky sci-fi elevator music. The SpaceX suborbital drift. Whoa, that's a fucking sick picture. Wow, I just reposted it on Twitter. Wowie. About 2 minutes until that relight test. Raptor relight test. If their timeline is to be believed. Fingers crossed on the relight. Let me just do it.
right, welcome back, everybody. If you're just joining us, Starship just successfully deployed its first ever payload. We got 8 of those Starlink simulators
successful
out,
payload deploy.
And now we are expecting the relight of a single
well, not a real
Raptor
payload
engine. That should be
a
coming
payload
up
simulator
just a
deployed.
little under a minute. We're going to be
but
lighting
still,
just
important.
one of those Raptor sea levels in the middle
right
there.
Now they're over Africa.
This is not a deorbit burn. It's a demonstration of what we'll have to do for deorbit burns. But we've done this once before. This is something we're really going to have to do when we're doing orbital missions. So it's a pretty critical test. We are just a couple seconds away.
Alrighty. Fingers crossed. Let's go relight.
Sorry, we're about 20 seconds away, psych. So we got a little bit more time. So we are going to see one of those Raptor engines light back up. We are through the deorbit demo gate, so we should be seeing it momentarily.
Relight demo startup.
Okay, startup. Okay.
And shutdown.
There it is. That looked clean.
All right, looks like we confirmed
that
the
relight
good. Of one of those center Raptor engines. Second time we've done that. Super exciting. Huge congrats to the team on this milestone. Very exciting to see.
That was a cool light show. Yeah, I get to do a mini version here. So again, that's going to be really critical for when we're doing deorbit burns. Like as you're going through, which if you don't have one of these, my God, they're so much fun. But like you're able to actually like light. Oh, Dan, turn it on. Light that engine. Not set my co-host on fire. And that's what we'll eventually do to, break out of orbit, come back down to Earth. So really cool to see one of those engines light back up again in space. That was our last.
The ship looks like it's on a really good line too.
Very exciting. We're going to be heading back for
helicoptering across the atmosphere this time.
We're going to take another quick break, and we will see you soon.
All right, nice. The lonely, empty inside of Starship after its payload test has concluded. That was pretty much all you can hope for in a launch, to be honest with you. I'm very happy with that. Everybody on space Twitter just losing their minds. Did I pause it? I definitely did. I was like, why isn't it moving? Why is the timer not counting? Well, what's that little dangly bit there? We got some dangly bits. We'll have to wait till we hit more sunlight to see that for real. Well, you can see some clouds below, so we're starting to get back into the light here. Maybe some initial plasma buildup as well. Starting. Either that or that's just venting, catching the light high up in the atmosphere, which it probably is. But we are going to start to see them begin to re-enter eventually here. They are getting pretty close to the Indian Ocean. Crossed over top of Africa now, headed towards Madagascar. Should start to get more light the further east they get. Let's see, we got this little graphic is awesome to be able to know like the orientation to north of where the ship is actually facing and whatnot. This would have been so fucking funny, like last time or whatever when it was spinning, just like. Oh man. I hope. I mean, I don't. But like, man, would it ever be nice to have that telemetry marker while it is doing like a hypersonic, Beyblade maneuver? Okay, that looks like plasma buildup is maybe starting now. Sort of hard to tell. Yeah, I think it is. Oh, what the fuck? Well, that doesn't. Hold up, guy. That looks like some wiggly bits and some steel. Shredded steel. That's probably going to melt pretty quickly, I would wager. But we've seen it survive with much worse damage than that, so we'll see. This flap looks nice. No damage to this flap. It's that that aft flap, or is this the aft flap? This must be the aft flap. So it's that front flap that's all boned, all screwed up and boned, with its like back half like shredded. Wonder what that's all about. Oh yeah, now we're really starting to get that glow of heating from the plasma.
All right, so we are back. So we are about 45 minutes into the 10th flight test of Starship. And as you can see, the light show has started. Re-entry has begun. We are starting to re-enter the Earth's atmosphere. We're moving about 5 times the speed of sound, and we're about to start barreling through the Earth's atmosphere and head for a splashdown in the Indian Ocean. We don't plan to recover the spacecraft today, but if we do make it all the way down to the water, who knows? But the goal of this part of the flight is to learn as much as we can about the ship's heat shield. A fully reusable, rapidly reusable heat shield for a spacecraft has never been done before. It's one of kind of the hardest engineering challenges still out there for us. And so this is a time to really dig in and get that data.
Yeah, absolutely. And re-entry is a critical phase of flight, so we'll need information on how the ship's system ends up performing. And Starlink will also help us gather as much data as possible, which is really the main reason why we do these flight tests. Starlink provides us with one more path to collect data to help us rapidly iterate on Starship's design. And if the ship manages to make it all the way to re-entry, we'll collect valuable data on the spacecraft flying through the Earth's atmosphere at hypersonic speeds or more than 5 times the speed of sound.
Yeah, throughout history, a lot of times this is when you go into just a complete data and insight blackout, where that plasma sheath builds up around the outside of the spacecraft that blocks all of your signals that are trying to fight through to talk to either
they have a
satellites
really cool solution
out in
for
space
that.
or towers down on the ground. Starship's big size kind of gives us a wake, but what really helps us punch through is the fact that we're using Starlink. We're operating at just a much higher frequency. That's not what we want to see. So we just saw some of the aft skirt just take a hit. So we've got some visible damage on the aft skirt. We're continue to re-enter though. And again, we are intentionally stressing the ship as we go through.
They have a piece going helicopter at the back
there. It is not guaranteed to be a smooth ride down to the Indian Ocean. We've
Whoa.
removed a bunch of tiles,
excitement guaranteed
kind of critical places across the vehicle. So seeing stuff like that is still valuable to us. We are trying to kind of push this vehicle to the limits to learn what it's like as we design our next version of Starship. So
just very like abrupt, like shake, and then everything sort of exploded at the bottom there.
Excitement ticking up a little
but
bit.
The ship still is mostly
already,
intact. So
but the light show is continuing. This reentry
is going
to take about 20 minutes or so until our planned splashdown. We were trying to splash
look
down.
At the stuff coming off.
6 minutes into
the material just tearing off and the beautiful sparkles.
Yeah, and one day Starship is designed to land on Mars, where there are obviously no runways or other humans to help us out. So we are doing propulsive landing instead of more traditional means such as parachutes. And propulsive landing.
I wonder if the engines survive that.
Rapid reusability
like if they make it through, will they actually even be able to relight them?
Yeah, the ship itself
that seemed relatively
little
bad.
over 50 meters tall. We've got those 6 engines on board, the 3 vacuum, the 3 sea level,
rainbow.
And they're down in that aft skirt region, which
flaps have control.
Flaps have control.
Right, so
okay,
at this point,
so
the
just
flaps have control.
The engine bells look okay. It just looks like
the atmosphere
that doesn't look
very good. The flaps
can
start controlling us. We're not only reliant on those kind of reaction control system thrusters.
We're going to continue hearing some call-outs as the ship makes its way back to Earth. So when we hear
hypersonic drift through the atmosphere,
that will mean the ship has made it through the maximum heating and aerodynamic loads it will experience as it returns. So if it makes it through those, we can say we're doing pretty well.
I will say I'm happy re-entry cleaned off this camera for us. It was a little dirty from the weather, so thank you, Plasma, for giving us this view as we start coming down.
Wow. Well, 1 second. I gotta like get my face out of the way there.
Hit we saw to the
we're like
skirt,
missing out on all the
I will note
the taste of the rainbow.
These missing tile
I was like circling
it,
but my face was in the way.
Removing them only in the skirt.
Wow, that's a lot of material coming off.
That's not over your fuel tanks or anything else. That's kind of structurally critical for keeping the entire vehicle together. That obviously exposes your engines. So that could do some
poor
things for our landing
bit.
burn.
I wonder when that's going to tear off.
For now, we are obviously continuing with this reentry. We are committed. Indian Ocean, here we come. 50 minutes since launch. We're going to see those colors start to build up a little bit.
Yeah,
we are at the point where we're in dense enough atmosphere that the flaps have control. It's all about 74 kilometers in altitude.
That speed is really starting to drop now.
We're starting to see some sunlight, so we intentionally time these launches right now so we have daylight. The sun should actually come up over the horizon on Starship in about 3 minutes. So as we get a little bit further into this reentry, that inky black below you is going to start to look like clouds and hopefully a bright blue ocean as we make our way down onto the other side of the planet.
The wiggly bits are melting away.
We've got these cameras. These cameras are really cool. We added these several flights ago, looking directly at the flaps as not
whatever
just the
that
is
resilient
flaps,
as
how
hell.
They're able to control the vehicle, withstand
surviving Mach 5
the seal location
through the atmosphere,
where they connect to the ship itself.
Doing it again.
Are some of the most critical.
A little tape.
We will do missing
There's no good
tiles
spot
on
for
those
me to be.
where again we're trying to we're kind of being mean to this Starship a little bit. We're really
like
trying
this.
to put it through the paces and kind of poke on what some of its weak points are. I mean, we even have missing
annoying
tiles
for clipping
over some of those fuel tank
I want to be able to show off as much of the wacklery as possible.
We're
I think
really
this is a good
trying
spot.
to see what are our limits We're doing this over a completely empty area over the Earth. Look at our Raptors there. We are, assuming we make it all the way down to the ocean in one piece, we will attempt a flip and a landing burn. We do have at least one buoy, everybody's favorite camera person, out in the Indian Ocean right now, being powered by Starlink. So that's at our planned landing location. So if we're able to get any live views of the ship, that'll essentially tell you that we nailed our target. Able to do that on our 6th flight test. Do it in the daytime.
That doesn't look
really
very
exciting.
good. That looks like a lot of burn through. Yo. That like looks actually insane. That looks crazy. Like that looks nuts.
All right, so we're about 10 minutes until we're probably going to start hearing some of the other big milestones.
All the little bits of steel just turning
in about
into
10 minutes,
like
sparks
said, and just
Starship will be
flying
transonic.
away at Mach 23.
This is going to be the period of flight where the velocities of airflow surrounding and flowing past the vehicle are concurrently below, at, and above the speed of sound, so somewhere in the range of Mach 0.8 to 1.2. For reference, commercial jets have a range of cruising speeds, but most of them fly at speeds between Mach 0.74 and Mach 0.85.
Meanwhile, this is going Mach 20.
480 to 575 miles per hour, or 770 to 930 kilometers per hour.
Yeah, and after transonic comes subsonic. That just means you're slower than the speed of sound. We're still well in excess of that right now. But by the time we hit subsonic,
you don't say. And now we're starting to get that the light side
down.
of the
there
Earth.
There we go. There's
again.
that sunlight.
The sunlight.
So we're seeing the Earth now come back into view. One of the other things we're doing during this, and you're going to see Starship kind of pitch in some pretty, not extreme ways, but a little extreme, as we're trying to really stress the structure of the ship itself, specifically those aft flaps, so the ones in the very bottom of the vehicle. We're pushing not just how well does the heat shield hold up, but how well does the ship structure hold up. We are
definitely looks like it has some wiggly bits, which is not ideal.
We'll have to fly at,
but that's okay.
To do something like a return to launch site. So again, may not be a very smooth ride downhill. But we're doing that by design. We're really trying to find what are the edges that we can operate at, build up a good data set. But sun is up, clouds and water down below us. We are just about 10
My
minutes.
God, and then here I'm in the way. I can't win. No matter where I put this fucking camera, guys.
We hit subsonic,
I have to move it like every 5 minutes. I love that, dude. Oh, so good. Wow, we haven't gotten this in so long. This is such a great thing to see. That thick layer of plasma built up along the flap there, which is sort of acting like a protective layer against a lot of the other plasma. Like film cools itself. Kind of cool.
All right, so about 55.5 minutes in, you can see the sun is up. Again, we intentionally designed these flights to lift off in the evening here so we get these daylight views so we can get as good a video as possible on the ship, assuming
Look at
we
those
make clouds
it all the way down there.
We've got
so
at least
cool to
one
see them from this
buoy
altitude.
Powered by Starlink that's out there
and at this
in
speed,
the landing zone.
Just
in
seeing
the
all the different
Ocean,
patterns go by.
Giving us a view again. If you see any live views, not from the ship itself, that means we nailed.
The ship is really slowing
down
now.
Past peak heating.
Yeah.
All right, we just heard the call out that we're past peak.
We'll see a lot of that heavier plasma rip away now.
Looking good. And at this point, again, the
this
flaps
is very
are controlling.
good.
So this movement you're seeing is that forward flap moving to try and just maintain control, maintain attitude of the vehicle as we're coming down.
Yeah, you can see that layer thinning. It was a lot thicker and whiter before. The flaps have held up very well this time, I will say. Aside from there's a couple parts of them that are damaged pretty badly.
On one of our flaps,
it looks really good.
Got one of these cameras on all 4 of the flaps, 2 in the front, 2 in the back, giving us really good.
Like that doesn't look really good, but
as we
and right there as well, those edges at the back
shield. That's
really
give us kind of the best that we can do.
Really struggle.
But looking at those flaps is really those are just super critical for controlling the ship. You have some ability to maneuver kind of cross range. So as you're coming in, you can see in that indicator at the very bottom right that we've pitched up quite a bit.
There, that's
so again,
melting
we
through,
are
but not too badly.
We are maximally stressing those aft flaps right now.
Yeah, you don't say.
Looks like we got a little bit of burn through the very bottom part of it.
On both sides.
Everything's still looking good. Ship maintaining control. We should be just about 5 minutes away until we hear that we're transonic.
Well, it's still going really fast. But now I guess that it's as low as it is, it's really going to start to slow down. Look at all that just slag melting away. There it goes, finally. Oh, that wiggly bit is really wiggly, huh? Dang.
Still a little bit toasty on the aft skirt of the vehicle as we continue coming in.
Again, we are intentionally stressing the flaps so we can learn all we can.
Something was wrong with this one before plasma, though. Something had gone wrong with this.
We're already
because it was already torn up. Oh my God, I have to sort of move again, don't I? But this flap was already torn up before.
Just about 48, 49, counting down to 48.
Before the plasma started building up.
Expecting that transonic to come, so transitioning between the speed of sound and subsonic slower than the speed of sound.
Yeah, well now they're really slowing down. We're seeing like an absolutely immense slowdown, which is
right now
really
we've
cool.
got kind of a lot of forward momentum, a lot of forward velocity, and then eventually by the time we hit subsonic.
Yeah.
All right, here we go. So this is what we've been talking about, where we are going to essentially try to fully deploy those aft flaps and really stress them out. So
are they going to rip off?
This is meant to test the extremes for the vehicle.
Oh, look at that heating. Holy crap. Look at that. Damn. Wow. Oh my God. It's flapping its wings like a bird. Look at it.
All right.
Don't start spinning. Hold it together.
See those flaps swinging out? Again, we're putting ship through the ringer on this flight in.
It's flapping its wings like a bird. Oh. Wow, it really slowed down.
It's like we're still maintaining control.
Still going very fast, though. But the fact that the flaps are still actuating is pretty impressive.
Flaps earned their paycheck today.
Yeah, they did.
Kind of that max stressing.
Wowie.
Definitely things looking good so far. We're about 2 minutes out now from Starship becoming transonic.
One cool thing to note as we get some of those views showing kind of the whole length of the ship. One of the changes we made after
Flight is that a heat tile
to
bouncing around?
Change the tile line a little bit. So we had kind of scaled back the number of tiles significantly. As when we go to catch these ships, you don't want to. I think as Elon said, you don't want to shuck the ship as you catch it and knock all those tiles off. So we knew we were going to have to kind of peel back that layer a little bit.
Peel
and the first
back.
time we did it was
Banana
on Flight 6,
jokes,
and we
dude.
saw kind of
once again,
dimples almost in the
second.
ship as we were creating these hot spots in the uneven parts of the heat shield.
Once again, I'm putting myself always in the camera view.
Address that. We smoothed it out. That's why you've got
this is going to be a nightmare to go back and clip, but that's okay. That's okay. That's a me problem. I will solve that problem on my own.
A little bit of warping almost. Near the payload door, you can see a little bit of colored patina up above it, but we don't see those kind of deep, almost.
Oh, that's really cool. Look at that.
They almost look like gouges.
The wave
on that, so
of
it
the
looks
heating?
like that's been pretty successful. So.
Really interesting that.
All right, we are less than a minute away from hitting transonic.
Yep.
Again, pretty soon our kind of
Mach 2 now
velocity is going to look like it's kind of falling off a cliff, and Starship will look like it's falling off a cliff as we.
It is falling off a cliff.
Our belly
the space cliff.
Watch some of the high altitude tests or suborbital campaigns. We were able to test that. It was a pretty fundamental, like, can this thing actually fly? And we were able to prove that out with that suborbital campaign. And that's what we're about to see shortly here.
All right. And back below. Almost back below the sound barrier.
All right, so at this point, we've dropped below the speed of sound, so Starship itself is subsonic. We are starting
and now it's going to do its belly flop maneuver, I believe, right?
For a landing burn attempt. Landing flip supposed to start in a little over 2 minutes. Subsonic Indian Ocean, we're on our way.
Starship is subsonic.
There we go.
Wow, this is a hell of a view.
Farewell space.
That flap has taken a hammering, but it looks okay on the front end. It's just that back bit that needs a bit more. Needs a bit more work on it.
Coming up in just a little under 2 minutes, so we're going to do the flip and the burn. So we're only using those 3 center Raptor engines, the sea levels, the ones that can kind of gimbal, that can move around and steer. Dipping the nose down a little bit. Got 2 of
10-kilometer
our engines
altitude.
chilled in, waiting on 1 more. So again, we'll attempt to use 3 burns for that initial flip. We eventually
look at
go
that
down
steel
to just 2
peeling
Raptors
away.
At the end of the landing burn.
Flapping like it. Farewell to flaps.
1 minute now from that landing flip and landing.
That flap is flapping. Oh, some of those came off. The empty pins. No, the camera's going to be all goobered up. We're not going to be able to see. This one should be good, though.
Structurally, we're looking good. Got good pressures in our nose cone for everything.
Okay. So we'll see that flip and that burn very soon here.
Again, we're going to look for the flip.
They're going to punch right through this cloud there. The ocean is going to be approaching very rapidly.
Swing
2,000 meters.
Punch through some clouds first.
1,800 meters. 1,500 meters. There's the ocean. We love the ocean.
Here we go.
1,000 meters.
Starship landing burn startup.
Flip success.
Seeing 3 engines.
Oh yeah.
There's our flip.
Buoy cam, yes, buoy.
There's a buoy.
Yeah, look at that go.
There's a splashdown.
Huge, and then it explodes. Yeah. Woo! What a frame to freeze on, yeah. Congratulations to the SpaceX team again.
Oh man, yeah.
What a good job on that.
Thank you, buoy
Flight
cam.
10, very
landing
successful.
Flip, landing burn, splash out of the Indian Ocean. There we go. All right. That was pretty awesome.
Incredible flight.
That was pretty awesome.
For both ship and booster.
Yeah, really incredible. So obviously we're excited here. It looks like everybody's excited over there. Tyler, how's it going over in Hawthorne?
We are super excited here in Hawthorne. It was another
today's been a very exciting
flight
launch.
test in the books, and we hope you enjoyed those Starlink views. So congratulations to the team at Starbase and everyone here and around the company. So many employees have contributed enormously to the Starship program as we continue to iterate and make progress towards a multi-planetary future. So that's going to wrap it up for us here in Hawthorne. Thank you to everyone for tuning in today. It was great being with you
thank you everybody as well
you
on my end. Appreciate you. Hope you all have a good rest of your night.
That was absolutely incredible.
Very exciting. This launch went really well. So look forward to Flight 11.
We lifted off from Starbase, Texas, right at the top of our window at 6:30 p.m. Central Time. We saw a booster successfully lift us up through ascent, had a successful hot staging where ship continued on with its suborbital trajectory. Booster came back down, had that boost back burn, and a successful landing burn with that unique engine configuration as well.
Yeah, and then ship continued on its way, made it all the way into space. We got to see first ever payload deploy.
So exciting.
That
very
was awesome.
Cool.
We got the
that
door open, cool. 8 Starlink simulators deployed, relit that Raptor engine, and then on entry we probably gave it a little bit of extra time in the oven, but made it all the way through re-entry. All 3 engines started up, landing flip, splash down in the Indian Ocean. Promised maximum excitement. Starship delivered.
Most
so
definitely.
Congratulations, all of our teammates here at SpaceX.
Yeah, congratulations everybody at SpaceX.
Everybody that's
what a
working
crazy
this program. This is what we're
what a
working
crazy
for,
year
so
of launches.
Big congrats to all of them. Thank you.
Looking
to all
forward
of our
to
future
another year
customers,
next
too,
year
for your support.
of crazy launches.
And we'd also like to thank the fine people of Cameron County, including the residents of its newest city, Star.
We'll head off of here now. Head on over here. All right, well, that's going to wrap it up for Flight 10, everybody. The reaction to it. I appreciate everybody who popped by, anybody who popped by afterwards and watches it back. That was not as exciting as some of the past ones because we didn't have the booster catch and whatever, but no super bad destruction this time where the ship tears itself apart. They actually got the splashdown, got a lot more data. They got that engine relight, they got the heat shield testing that they needed to do, and they got the payload deploy. So very awesome, and yeah, we'll keep our eyes open for Flight 11, and I hope to catch you on that one as well. Anyway, peace, love, and happiness. I'm gonna go play some Factorio. Y'all have a good rest of your Tuesday evening. Bye bye.